All right, so we were talking about okay, so we were talking about exploration and exploitation. What is exploration? So visiting the states that you have not visited before, and exploitation means, I mean, just use the current states. This is the best I know, and just keep visiting those. Okay. How to explore? One way was epsilon greedy. So this is a very famous way of doing it. Epsilon greedy. What is epsilon greedy? What algorithm is this? So with small probability epsilon, you act randomly, and with large probability 1 minus epsilon, you act on the current policy that you have learned. Okay. Any questions in this part? Problems with the random actions? We have seen it here. So I think, yeah, we have run these two things. Now, okay, so this is a new slide. We have seen exploration functions before. What are exploration functions? What are exploration functions? किस कॉन्टेक्स्ट में देखा था पहले? Which case में? See, we were trying to look for, we were trying to approximate those terminal values, right? So we had seen exploration functions before. When, for example, when we were talking about, okay, so the name was not exploration, so forget it. What we did was evaluation functions, okay? When to explore? When to explore? Random actions explore a fixed amount. Better idea is to explore areas whose badness is not yet established. Eventually stop exploring. So what are random actions? So question is, how were we exploring in case of epsilon greedy algorithm? How are we exploring in case of epsilon greedy algorithm?
We were in general going on the same states with a small probability we were relying on random states.
So what impact will it have on, so let's say you have learnt a policy, okay? What impact will it have on your actions according to that policy? How many of you understand what is this? Raise your hands एक बार. How many of you don't? It's okay to raise hands. मेरे लिए अच्छा है वो. Okay. And now how many of you want to know what is this? All right. Good enough. So what is epsilon greedy? देखो what is exploration first of all? I'll do this quickly rather. What is exploration? What is exploration? देखो, if you are trying to figure out a policy, right, what options do you have? How many of you know what is a policy? एक बार अच्छे से raise your hands. How many of you know what is a policy? Okay, चलो. We still have 50% who don't know what is a policy. So, exploration means go and explore the new state that you have not been to. Okay? Exploitation means just continue your current learning. So, if you have learnt about some states, good, bad, etc., okay, you just continue with whatever you have had your learning till now. Exploration means something new, some new state that you are supposed to explore. So now in this case we are saying how should you explore, right? What does epsilon greedy do? I mean, this is the simplest thing you can think of. You don't have to be in third year BTech to understand this. 8th class thing. What is it? If I am in this state, so I am in this particular state right now, how should I take my actions? How should I choose my actions? What does epsilon greedy tell me? So let's say epsilon is 0.1. So with 0.1 probability, what will I do? I will act randomly. What does it mean randomly? I can go forward, I can go backward, I can go right, I can go left. But what will I do with probability 0.9? If in this particular state I have learnt previously that I should take a forward step. So what will I do now according to epsilon greedy? With probability 0.9 I will take a forward step, and with probability 0.1 I will go randomly. This is what epsilon greedy is, right? Very simple thing. You are in a state, you know some values, you have learnt them, but there is another thing available to you which is a random action. So either you go according to your policy that you have just learned, right? And what is the other thing? Act randomly. दो ही options हैं. एक जो आपने अभी तक सीखा है, act according to that, and another one is act randomly. What epsilon greedy does? Combine both. So whatever you have seen until now, whatever your learnings are, you will use those learnings 90% of the times, but 10% of the times you are going to make random moves. What is the benefit of this? What is the benefit of this? Say that again.
Since we don't have a perfect policy,
Right.
and we currently don't have, like, we don't we follow the right one, we act like to see if we can get that optimal.
We will explore, but we won't explore too much.
No. So
But following other paths other than the current policy may give us the.
no. I want a much simpler answer. So, what do I miss if I don't explore? Let me put it this way. What do I miss if I don't explore?
Best possible option.
See, we had seen an example of this. So, let's say keep a very simple grid, right? Let's say from here, I know I will, in fact, forget even this as well. Are blue and red machines. What was the characteristics of blue? Always $1. Okay. What were the characteristics of red? 0 or $2, $2 with probability 0.75 and 0 with probability 0.25. Now if I always go to blue machine, what is it that I am doing? So let's say, in fact, let me take my statement back. Right now I don't know. I let's say go to blue. I pull the lever and get $1. Right? So I now know that I can get $1 from this machine. Do I have any other idea? I don't even know whether it can give me 2, 10, 100. I don't know. Right? What do? I press blue lever again. I get $1. Let's say I keep on doing this. What is it that I am doing? This is I am exploiting. Exploiting what? Exploiting my prior knowledge. That, and prior knowledge is now consolidating. Blue always gives me $1. Now question here is what is exploration? Exploration means, so what is that is untouched until now? Red machine. So if I keep on getting that $1 from blue machine, that would be exploitation. I have never been to red. If this time I go to red, what does it mean in this terminology? I am exploring now. Okay. So you go to red, explore. I pull the lever, I get 0. What will I do? Right? So maybe go to blue again, but once in a while you will come back to red to see कि भैया हर बार थोड़ी 0 आएगा. You pull that again and then you get 2. So your strategies will, right? So if let's say what I do is this now, 90% of the times I will pull the blue machine and 10% of the times I will go with red one. So what is epsilon greedy in this case? So what is epsilon? 0.1, because I am acting randomly 10% of the times. अब उस 10% of the times में I can end up pulling blue as well, right? But there is a chance that I can pull the red trigger. Okay.
So what is the good decent value of such? Generally, क्या use है?
So generally this will be a very small value, but initially you will have it high. भाई suppose करो, initially you have to have it high. So for example, take this blue red case. If you have a high epsilon, then maybe after, so let's say if you have epsilon is 0.5, after trying blue once, the probability that you will try red is 0.5. Okay. But if your epsilon is very high, right, or very low, 0.1, what does it mean? 90% of the times I will just go to blue and only 10% of the times I will try red. So initially keeping this high is a good idea because you have a lot to explore. Later when you don't have much to explore, then this thing should decrease. Let me run this again. So in fact let us run
Here's the crawler. And now you can finally see what this
ये सारे differences notice करना. Okay.
epsilon control here is. This means 80% of the time we take a random action. That's a
Epsilon is 0.8. That means 80% of the times we'll do random actions. Okay.
lot of exploration. It's not, however, a lot of progress. Now, will this work? Q-learning works just fine with lots of random actions. It just doesn't necessarily work quickly. So I skip some steps. And we've got some big...
So note that skipped 30,000 steps. What does it mean? 30,000 episodes skipped. What does it mean? So you have fast forward the iterations 30,000 times in the backend. Yani ki you have done this thing, state, action, S prime, got a reward. How many times have you done it? 30,000 times. Usko skip kar diya. Okay?
Blue. I'm going to skip a million steps.
But you see, even after skipping 30,000, nothing is happening. So now he says he is going to skip a million steps.
Right? So we compute, and now it actually turns out that this bot has had a lot of experiences here, even though I fast forward it.
So if you have shown your bot, this one, more than 1 million experiences, what do you expect? It should have learned something. But then if it has learned something, then why is it
Presumably
not
it should have
reflecting
learned
here?
something. Why is it not making any progress?
Because it has learned a lot.
So
So मतलब पिता को सीख है तो it's finding difficult to कौन सा action use करना चाहिए उसको.
So just one question. When you say you have learned something, what is it that you have actually learned? Because you are using Q learning here. Actions in a particular state. So it should be able to move forward. Why is it not able to move forward?
Well, we're forcing it to act randomly 80% of the time, right? Whenever you walk,
So here he just answered. What is it? Right. So epsilon is very high. But you might, so for example, there are these two things now. For every state, I know what to do. Okay? And that what to do is optimal. We have run our system for more than 1 million steps. So I know for every state what action to take, and that action is most likely optimal. But if in every state I am taking action like this, that 80% of the times I will go random, what does it mean? I am just trashing away whatever I have learned, because I am not using that at all. भाई मैं अभी भी हर स्टेट में 80% तो randomly चल रहा हूँ ना, so that's why it's not making any progress. Now when you see if epsilon he makes it 0, that means what does it mean? Epsilon is 0. Don't explore, don't do any random actions. जो policy आपने अभी तक सीख ली है, just use that, exploit that. Okay?
if your left leg 80% of the time flew out at some random angle, you wouldn't make fast progress. Okay, so what happens if I turn epsilon down? Let's turn it off. Just let it go. Be optimal. Right? Well, it's not so bad, right? So you already learned the right thing, but the exploration was preventing you from doing it. So there were a couple issues there. Let's see what they were.
Okay? So exploration is good, right? It helps you figure out those states also which you have never visited before, like our blue and red thing. See, which strategy was the best, the optimal one, जब अपन blue and red वाली machine कर रहे थे? Let's say if you knew this thing, if you knew the whole MDP beforehand, what was the best thing to do? We did this before. If you have 100 chances to pull the lever, what will you do? All red, because 0.75 was for $2. That will give you 150 compared to 100 of blue. But you could say so because you knew T and R. In this case, you don't know. All right, now we come back to what we were discussing. So exploration functions. One way to explore was epsilon greedy. Now we are talking about other ways. So when to explore? Random actions explore a fixed amount. At which time of training it is good to take random actions? Initially, right? Because initially you have not been anywhere. Random will take you almost a lot of these places. A better idea is to explore areas whose badness is not yet established. Eventually stop exploring. Exploration function takes a value estimate u and a visit count n and returns an optimistic utility, this one. Regular update is this. What is this update? If I have a class in which 50% don't know what is a policy, how many of you know what is this update? Can you raise your hand? What is this regular queue update? How many of you know what is this regular queue update? Raise your hands. थोड़ा I'm not going to counter ask you. I just want to know the people raising hands. Okay. So what is regular queue update? देखो, I don't think we are doing anything fancy here. Okay. Class भी आ रहे हो. So either tell me I'm not doing it right. Right? Ask it in the class itself. मतलब क्लास भी आ रहे हो एंड देन नहीं पता, these two things don't go together. Yes. What is this? So your QSA is same as just one step what has happened, right? This is your sample. How were we updating? Can anybody give me equation? फिर आगे आएगी. Modified. So we were updating just because of, in earlier version what were we doing? You will take an observation and update the current queue based on that observation. अब अपनी इस इक्वेशन को अपन ने कैसे लिखा था? My current queue is equal to what? बिना कहीं पे भी देखे. My current queue is equal to 1 minus alpha times the older Q value plus alpha times the sample, right? So tell me again, when will I have good Q values? At which time of my training? Initially or after some 1 million steps? Initially, how will my Qs look like? Whatever they are, they will be very far from, I mean, on an average, they will be very far from optimal values. Okay? You need to keep updating them. Now, what is this 1 minus alpha times older plus alpha times the current sample? Current sample. How does that help us? देखो, Q equal to 1 minus alpha times Q. This is almost an equation like A equal to A plus 1. Is it? भाई जो प्रोग्रामिंग में सिंपल सी इक्वेशन लिखते हो A equal to A plus 1, this is same as that, just that जो A है वहां पे write that 1 minus alpha का फैक्टर and 1 के साथ में अल्फा मल्टीप्लाई कर दो. This is as simple as this. Okay, so you are updating. So whatever this equation is, for those who are not getting it, this is same as A equal to A plus 1. Just that A equal to A plus 1 जो है इसको मल्टीप्लाई कर दो 1 माइनस अल्फा से, इसको मल्टीप्लाई कर दो अल्फा से एंड राइट इन टर्म्स ऑफ डिफरेंट वेरिएबल्स हियर. वहां पे जो आपके वेरिएबल A था that will become something else. That's it. Now how are we modifying it? यहां पे देखो, this remains the same, nothing changes here. What happens here? This was max of Q value. Here you have modified it. Max of some function of Q value and N. What is N? देखो, I'll compare it with random again. I am doing epsilon greedy. That means in every state I will take random actions with probability epsilon and deterministic ones with probability 1 minus epsilon. Okay? Deterministic means according to my policy. What is happening in this case now? What is this F? This F is a function of Q value and what is this N? So N is number of times you have been in a state. So if N equal to 0, you divide by 0, we don't want that. So let's say you add plus 1 to it, or N is not equal to 0, essentially say that. Okay. Now tell me, what will be FUN? So this U is nothing but your coming from your Q values. What is FUN? Q values plus some K by N. If I have not visited a state even single time, what will be the value of this quantity? I have not visited a particular state, so how will FUN be decided?
वहाँ पे आप रखना चाह रहे हो
देखो, okay. F will be higher in which case? Small n or bigger n's? Keeping u as a constant, FUN will be greater for smaller n's and smaller for large n's. So if n tends to infinity, f of un is u. Okay? If n is 1, then f of un takes its maximum, provided all these quantities are positive. Okay? एप्सिलॉन ग्रीडी में क्या कर रहे थे एक्सप्लोरेशन में अपन? सिंपल, एप्सिलॉन टाइम्स रैंडम एंड 1 minus epsilon times according to policy. In this case, you are saying you get more reward. Your F is higher if you go and visit those states which you have never visited. So n is the number of times a state has been visited, let's say. If a state has not been visited even a single time, what will be the value of f of un? U plus k. Okay. If I have visited this state 1000 times, what will be the value? Roughly u. U equal to k by 1000. Right? If now you want your things to happen in such a way that if higher f means, so this is your f. Which update would you like to have? This is max of a prime. Which update? Where f is the max. So you are somehow inbuilting in your function itself that if you have not visited a state, you get high values for it. See, flush everything. This was q values. What will this max ensure? I take the maximum q values. What is this max ensuring? I take the max f values. Okay. What is a f value? Something q, something u which is basically ये रहा देखो q. What is this other part k by n? Exploration के terms में देखो. What is f allowing you to do? F is allowing you to explore. कैसे? If you have visited a state 1000 times, what will be the value of f? Roughly u. But what will be the value of f if n is 0? U plus k. So, I mean max, right? So, if you have now two states, both u same, but for one you have visited 1000 times, another one you have visited or you have not visited even a single time. For which one f will be higher? The one which is not visited, right? So what is this particular exploration function trying to capture? If you have not visited a state, I give you higher reward for it. Okay, not reward, higher utility. This is forcing exploration, yes.
But we don't always want to explore.
Right, you don't always want to explore, but this is not forcing an exploration if n is, so if you have explored enough, I don't send you there. I only send you to places where you have not been to.
हाँ तो this is exploration ना.
हाँ.
Exploration तो वही हो जाएगा कि जो crawler जो है वो चलेगा नहीं.
No, that's a different thing. उसमें you were doing 80% of the time random actions.
नहीं but फिर इसमें भी तो हम exploration ही force कर रहे हैं.
So let's say all states you have visited infinitely many times. Your f reduces to q. This is same as everything here. But if you have states that you have not visited, I want you to visit them once. So not visiting scores me points. It says if there is a state I have not visited, this function will kind of make sure that I should go and visit it. Right? If whatever rewards values were there will be low, right? I'll probably not like to visit that again and so on. K is, let's say you can take any constant or it can be a function of something else. Questions here? कुछ कॉम्प्लिकेटेड नहीं है, सिंपल सी क्या बात कर रहे हैं. एक बार ये सब हटाओ, सारी इक्वेशंस. क्या कर रहे हैं? आई एम मेकिंग माई फंक्शन डिपेंडेंट ऑन द नंबर ऑफ टाइम्स आई हैव विजिटेड अ स्टेट. If I visited a state enough number of times, do I need to explore that again and again? I've been there. I know about that state. So मेरे को exploration का काम क्या था? Go and visit those states where you have not been to. And this function is allowing me to do that, right? And this function is allowing me to do that. बस इतनी सी बात कर रहे हैं यहाँ पे और कुछ नहीं बोला पूरी स्लाइड में. Does this make sense? Okay. So अब इसको कंपेयर करना इस डेमो से.
Here is that same bot, still doing a tiny bit of exploration through randomness, but it's implementing a exploration function. So this bot is implementing an exploration function. And as time goes on, the exploration function will contribute less and less. And what that means is that even though at the beginning it's trying all kinds of stuff, very quickly it figures out that it actually knows what those actions do. And the dominant behavior is now one of exploitation. And, it's a slightly weird policy, but he's off. Okay. So unlike the other one, which had to run millions of steps and then I had to turn its exploration off, this one is already moving after a very small number of iterations.
So what happened in this case now? How was it different from the previous one? देखो previous one, how was the crawler learning? So what we did when we were talking about epsilon greedy इस डेमो में, you were taking actions but you were moving 80% of the times randomly, so it was not working. This was one aspect. Another aspect was how were you exploring. So in this case, how are you exploring? You are exploring using a exploration function. Previously we had to skip once 30,000 times and once 1,000,000 times. That many episodes you need to show it to be to do an effective learning. In this case you did not skip this, you did not skip this. It was able to learn the right thing, right, in a very small number of observations. Why?
The last policy was better, but more steps to learn.
Last policy was
Better, but it took a lot of steps to learn. Go fast thing, rather than others, because it has explored a lot. But in this, it does not explode a lot, but it just quickly moves with a very close speed. Exploration function.
what happened in the last one. He said it was moving fast. Why so? Because you had shown it more than a million examples, right? It has explored enough. So most likely the policy has converged to a optimal policy. So when you turn off epsilon, it will take that optimal policy and will go fast. In this case, what has happened? You have not done this, you have not done this, you have not skipped, you have shown it to very few observations, right? And still it is able to move. Which one is better? And why so? Why is this one better? It is moving slowly, right? So the idea is, देखो, in whichever learning you are doing, right? One of the most important component is you don't need infinite or too many training examples. If you need too many training examples, then I mean, if you give infinite data to any machine learning thing, right, it will learn the right thing, very crudely speaking. But in this case, you have shown it a very small sample size and it is still able to learn how to crawl further. Okay. If this guy runs, let's say, I don't know how much, but let's say 10% of this, it will also start moving very fast because it will also converge to that optimal policy. Okay. Regret. So even if you learn the optimal policy, you still make mistakes along the way. You still make mistakes. So this is just a concept that, you know, you compare things. So even if you learn the optimal policy, you still make mistakes along the way. Regret is a measure of your total mistake cost, the difference between your expected rewards, including youthful suboptimality and optimal rewards. Minimizing regret goes beyond learning to be optimal. It requires optimal learning to be optimally learning. Example, random exploration and exploration functions both end up optimal, but random exploration has higher regret. So can anyone explain me this? Random exploration and exploration function. What was random exploration? No, what was random exploration? We have done this before. Epsilon greedy. Okay. Random exploration and exploration function. What was exploration function? Fn equal to u plus k by n. So it says both end up optimal. So eventually they will both give you optimal policies. But random exploration has higher regret. Why? See, why are we bringing this concept in? Right. To reduce future loss. Okay, but not really. What did you say, Paras? See, if you want to compare two ways of doing things, right? So, I am not reading any of this right now. I am focusing on this because we have seen both the examples. What happened in case of random exploration? You did so many actions, right? Some of them would be optimal, and a lot of them will be not optimal. What happened in case of exploration functions? See, if you see here, random exploration and exploration function both end up being optimal. दोनों के दोनों आपको optimal policies दे रहे हैं. So can I say both are equally good? How do you choose which one is better? The one for which regret is less. Okay? We don't want higher regret.
Regret is just based on the computation and
See, can you make regret equal to 0 in this case? It does not matter how are you computing it. So we are not really writing an equation for regret. We are not doing that right now. एक ही slide है इस पे, right? But we just want to know this concept. That's it. So no equations writing. My point here is, can regret be 0 no matter what you are using? In which case? No, but there is no such action.
in case of exploitation, कोई एक state follow करे policy को running just because computing everything.
Huh?
We have the opposite policy beforehand, we can have 0 regret.
Right. So zero regret means you already know how to solve this MDP, which we don't know in reinforcement learning. So you can't really have a zero regret. Okay. Why? Again, why? एक example तो वापस से. Just talk about grid world. Why?
एक्सप्लोर करेंगे तो मिस्टेक्स होंगी.
Exactly. Right. So this is where it says, even if you learn the optimal policy, you still make mistakes along the way. Right. तो reinforcement learning में you don't know anything about the environment, तो वहां पे आप जाओगे तो आप inevitably mistakes करोगे. Right. What is the probability कि पहली बार में you'll take up all the optimal steps? Right. Almost 0. Right. So regret is a measure of your total mistake cost. So in this case, this had mistake cost higher than this one. This is all this slide talks about. Okay. Approximate Q learning. Now this is where we are coming to the intersection of deep learning, machine learning and reinforcement learning. So basically deep learning and reinforcement learning, because you can see these days courses on deep reinforcement learning. So basic Q learning keeps a table of all Q values. What does it mean?
Like every node has a lot of values, so store करके रखना पड़ता है. वो Q values के maximum. They are using all state.
What does this line mean?
This state is this value.
So remember that grid world, उसमें अपन ने पूरा हर एक स्टेट का बनाया था. For all Q values we were having, so for every state we had 4 Q values, right? And we were maintaining this table. Think of वो जो पैकमैन वाली स्टेट्स थी शुरू में जो अपनी आई थी ना एकदम शुरू में कोर्स के 2 to the power 32 times those kind of things. अब उसके लिए how will you maintain a table? This was a very small grid world. You could maintain these things, but you can't really do it for a huge state space. In realistic situations, we cannot possibly learn about every single state. Too many states to visit them all in training, too many states to hold the Q tables in memory. Instead, we want to generalize, and it does not matter. आप एक कोर्स करो मशीन लर्निंग पे, 10 कोर्स करो, 50 कोर्स करो, सब कोर्सेज का देयर इज वन सिंगल मोटिव, generalization. If your machine learning algorithm does not generalize, you can trash it. Why? मतलब इसके मैं मेरे को नहीं आता, कुछ समझाना पड़ेगा तुमको मेरे को. नहीं तो लेकिन नुकसान क्या है इससे?
अगर देखे सैंपल पे वो कर रहा है तो सैंपल नहीं देखे तो उस पे टेस्ट करना है.
राइट. सो वट एवर यू सेड इज राइट, बट मेरे को कम समझ में आता है. हाँ
मेरा सैंपल है.
हाँ.
तो जो मेरी एल्गोरिथम या जो भी है वो उस पे काम कर रही है, लेकिन पूरी दुनिया उस सैंपल पे काम नहीं कर रही है.
राइट.
तो अपन को लाइक जनरलाइज करेंगे तो सब यूज कर पाएंगे उसे, और सिर्फ मैं मेरे एक पर्टिकुलर सैंपल के लिए यूज नहीं कर पाऊंगा।
Whatever you are saying is right, but मेरे को एक लाइन और चाहिए. I mean, see, if I were not to generalize, so let me frame my question in a better manner because I am not doing the right thing. So let's say if I don't want to generalize, do I need to do machine learning? Why not? You have an Excel sheet. This example के लिए label is this, right? You want to do machine learning only because you want to generalize. So this outcome of any machine learning course is by far the most important. Any machine learning must generalize well, because else तो आपके पास as he said Excel sheet है, however big it is, अगर आपके सारे एग्जाम्पल इसी से आने हैं, right? Why should I learn? I should simply give this example, whatever जो आंसर था, just output that. Okay? Okay, that is it. So I think it is a good point to stop. कल लैब होगी एंड हाँ एंड प्रोजेक्ट 0 कल इवेल्युएट होगा. सो करके आना. हाँ, जस्ट सेटअप है, कुछ नहीं है. हाँ हाँ. बट सो यूनिवर्सिटी पॉलिसी चीटिंग के मामले में बहुत स्ट्रिक्ट हो चुकी है. ओके, इट्स मच बेटर. मैंने क्या मार्क्स रखे थे? 2. फर्स्ट वाले के लिए था 2, लास्ट वाला वाज 12, सो 14 हो गया. लिख के दिया है मैंने यार. 2 4 7 11. सो तो फिर जो भी बच गया वो लास्ट है ना. 2 4 7 12, राइट? सो कल वाला इवेल्युएशन इज वर्थ 2 मार्क्स. 2 मार्क्स 100 में से ही है, राइट? सो मेक श्योर यू डू इट ऑन योर ओन. इफ यू आर नॉट एबल टू एक्सप्लेन थिंग्स टू मी, और मेरे को कुछ नहीं आता है, राइट? सो 2 में से 0. इफ चीटिंग इज कॉट फॉर द फर्स्ट टाइम, 2 में से 0. सेकेंड टाइम 25 में से 0. ये तो आप बोल रहे हो ना, सेटअप ही तो है.
चीटिंग क्या होती है? आपस में या फिर
किसी एक ने काम करा उसने शेयर कर दिया सब.
एग्जैक्टली.
तो वही चीज ऑनलाइन देखना नॉट चीटिंग.
यूज चैट जीपीटी. यूज चैट जीपीटी बट डू इट ऑन योर ओन. ये नहीं कि चैट जीपीटी भी किसी और ने यूज किया है.
चैट की हिस्ट्री भेज दी.
हाँ,
चैट की हिस्ट्री भेज दी.
राइट? डू इट ऑन योर ओन. आज की डेट में जो भी टूल्स आपके पास अवेलेबल हैं, फ्री और नॉट फ्री, एक्सेप्ट यही सॉल्यूशंस अगर किसी और ने पोस्ट कर रखे हैं, दैट इज नॉट अलाउड. ओके? सो अपार्ट फ्रॉम लुकिंग एट दी सॉल्यूशंस, और कोई और आपको बताए, एवरीथिंग इज फाइन. चैट जीपीटी यूज करो. दैट्स अ टूल दैट एग्जिस्ट. आई कांट रियली स्टॉप यू फ्रॉम यूजिंग दैट.